2016 question 2. Which of the following is the electron diagram? Only electrons in the outermost shells are shown of lithium sulfide. So first off, we need to know whether it's a covalent compound or an ionic compound. Lithium, as we know, it's a group 1 metal, and sulfide, which is sulfur basically, this is a nonmetal. So a metal plus a nonmetal, we know that it's definitely going to be an ionic compound. So this is an ionic compound. So ionic compounds, they're definitely going to have charges, they're ions, and you can immediately rule out A because that's a covalent compound. You don't see any charges there. So with the help of this now, first off, what are we supposed to do? So I'm going to get there. Okay, I'm going to teach you two methods. So you can do either one of them, whichever one you prefer. So the first method is first figuring out through the electronic arrangement. So lithium, it has an electronic arrangement of 2 and 1 because the atomic number is 3. And sulfur, on the other hand, the electronic arrangement is 2, 8, 6 because it has an atomic number of 16. Now, how can I make both of them stable? How can I make them stable? Of course, we need to form ions, right? So lithium ion, I can make it stable by removing this electron, right? I can remove this electron, I could lose it, I could donate it to sulfur. So sulfur would get this electron and it would form, now it will gain the electron and now it has 7 electrons. Now is sulfur stable? No, it's not stable because we're supposed to have 8 outermost shell electrons for sulfur. And remember, just a reminder, for lithium, in the first shell, only 2. That's already stable. That's good enough because of the doublet rule. For sulfur, it needs to follow the octet rule. So what can I do? Yep, I'm just going to go ahead and get another lithium atom. I'm going to lose another electron. And this time, this electron will move here. It will lose, or you could say it donates this electron to sulfur so that it forms 8 electrons here. So now we can go ahead and draw it. So lithium ion, how many did I use? I used 2 of them, right? So this is 1. This is the second one. And outermost shell electrons, because we've removed them all, I don't need to draw them because I removed them. And on the other hand, sulfur here, sulfur. So originally it had 6 electrons, right? I'm going to go ahead and draw 6 electrons. And now I've added 2 electrons that came from lithium. So those that came from lithium, I'm going to draw in the original color red. And here, now because I've added 2 extra electrons, the charge would be 2 negative here. So there you go. Now you can match this with the other options that you see, and only option C matches with our answer here. Okay, this is the first method. Now the second method, I'm going to do it on the left here, is you can do using the cross method formula to find the chemical formula actually. So lithium, you know lithium is in group 1, and all group 1 would form a charge of 1 positive charge. And sulfide, it's in group 6. It'll form a charge of, all group 6 elements will form a 2 negative charge. And then what you're going to do is you're going to take the number, whatever number the charge that is, and do the cross method that you have learned before. Do the same cross method thing. And what do you form? Here, lithium, what's the number on sulfur here? There's 2, right? So you bring it down here, 2. Maybe I'll use a different color so it's easier to see. So lithium, let's use this one. The original number is 2. I bring it down here. So it forms 2. And here, lithium here, there's no number here, but I'm going to bring it down anyway. So it's just 1 basically, right? But we're going to omit the 1. So here, what it means, this 2 on the lithium, it stands for there'll be 2 lithium ions. And does it make sense? Yep, it does make sense. Look here, there are 2 of them here. And sulfur, which is a sulfide ion here, what's the number next to it? There's no number. That means it's just by itself. It's just by itself. So here, sulfur by itself, and it makes sense. There's just 1 here. So there you go. Whichever one you prefer, either this first method here or this bottom left second method here, whichever one you're going to prefer, you can choose either one. But here, one thing to mention is the second method, you won't be able to see the charges or the outermost shell electrons like I've drawn in the first method. The second method is much quicker, it's much faster, so whichever you prefer. So answer for this, C.